All know that the internet has grown exponentially and to the external looking person smoothly. No one noticed it. How come? It is an outcome of a great architecture, both of the hardware but mainly of the software. For example, the network protocols are mostly software. And this means that if you need to upgrade something or fix a bug, you write some code in order to fix a bug in the internet. Most of the softwares are running on commodity hardware. So the socket is just an API, an abstraction. This abstraction allows applications, software code, to connect to the internet. When they connect to the internet, to the network, they connect to sockets. Here's the socket API as defined. Int socket, so the return value is int, and it receives three parameters: domain, type, and protocol. All three are ints. They are very generic and they basically support any internet connection. Any internet connection can be made, or any network connection can be made with the abstraction of a socket, be it UTP, TCP, whatever. Unix pipes. For example, if we look at the domain, it's an int. It's just an int. So you can pass anything. So the constant pf_inet is the internet. The constant pf_unix is a Unix pipe in the socket. The constant pf_packet is a direct network access which bypasses all the protocols such as TCP. So if you ask yourself, how come pipe and network connections how are they working? And you heard that they work by sockets. This is because the socket is an abstract connection to a network. It receives an int. In this int you can pass anything and you have specific constants, pf_inet for the internet, pf_unix for the Unix pipe. The second parameter, the type, is also an int to the socket in order to build the socket. The sock stream could be the byte stream, and the sock diagram could be of type. This is the type. So sock stream is of type. We are building a socket of type byte stream, and sock diagram we build a socket of type UDP, actually messages. So how does a server opens and accepts connections? Again, we have abstractions, interfaces, and API. We have three methods: the bind, the listen, and the accept. The bind method receives as already existing an identifier and pointer to the socket, and then the address to bind to, and the address length. So the bind method that servers are using is binding a new socket to an address, because the socket was an abstraction which said, I want to open a socket with this type, and it didn't specify the address, the actual address that we are going to bind to. And this is where the bind comes. And here you see the composition that each layer, each API focuses on its own responsibility. So the bind is responsible to take in a socket and binds it into a server address. The server address is a composition of the IP and the port. The port is an indirect pointer to a process. So again, we have some kind of abstraction. The port is the internety abstraction to pointing to a process. So we said we have the bind, we also have the listen and the accept. The listen specifies to a socket how many connections can depend on the address. So we see that it's also decoupled from the bind. The bind is specified to which address are we going to bind, And if you expected that the bind will specify how many connections can depend on the address, then not. There is another method, listen, which specifies how many connections can depend on the address. And then there is the third decoupling, the accept function in the API, which accepts again a pointer to a socket, a pointer to an address, and a pointer to the address length. Basically, what the accept does is the actual work of accepting a new connection from a client. And the address that we see in the accept is the remote participant address, the address of the remote participant. So we see that one of the main reasons that contributed to the exponential smooth growth of the internet was that we are based on softwares which run on commodity hardware. And we see as an example the socket API, which is a very general abstraction of applications connecting to the internet via sockets. And what is a socket? A socket is defined by a domain which just says what is the type of the socket. Is it an internet socket? Is it a Unix pipe socket or direct messages? Is it a byte stream socket or a messages type socket? And then we saw that we have three APIs for accepting connections. The bind, which says that this server is going to bind this socket to this address, basically the server side address of the socket. The listen, which specified more of implementation details of how many connections are we allowing to depend on this address. And the accept, which actually does the acception of the incoming connections. So I think this was very interesting to see from a software developer perspective how does connections and sockets and the internet in general is working. So thank you for listening and see you all guys next time.